Less than 40 years after World War II, Japan transformed from a nation that was nearly completely devastated into one of the world's leading economic and technological powers. With discipline, systems thinking, and bold innovations, the Japanese have continually amazed the world in many fields, especially in agriculture. Although only about 12% of Japan's land is suitable for farming, and most farmers are over 65 years old, the country still maintains one of the most valuable agricultural sectors in the world, generating nearly 70 billion USD annually and producing tens of millions of tons of high-quality agricultural products. So what is the secret that allows Japanese agriculture to remain resilient in the face of natural disasters, harsh climates, an aging population, and high production costs? In today's video, Agriculture Insight will explore the fascinating paradoxes of Japanese agriculture, where total output may not lead the world, but the value created per square meter of farmland ranks among the highest on the planet. Now, let's begin. Japanese Fuji apples, often up to 3 times larger than typical industrial apples, are known for their crisp texture, rich sweetness, and juiciness. So much so that every bite feels like tasting a spoonful of concentrated honey. They are a source of pride for Japan's apple industry, generating at least 2 billion USD annually from both domestic sales and exports. To secure this special position in the global apple market, Japanese farmers must follow a series of strict and meticulous cultivation processes, paying attention to even the smallest details. Let's begin the search for answers in Aomori, the apple capital of Japan. Every April, farmers carefully hand-pollinate individual apple blossoms to optimize the fruit-setting rate and ensure it is as high and uniform as possible. By early summer, when young apples have just begun to form, each fruit is wrapped in paper bags to completely isolate it from pests, while protecting the skin so it remains smooth and blemish-free. Throughout the growing process, farmers continuously thin the fruit, rotate the apples, and adjust their exposure to sunlight so that every apple can develop the most perfect size and color possible. After about 5 to 6 months of care and patience, Fuji apples reach their ideal ripeness, signaling the start of the harvest season. This stage is carried out entirely by hand to minimize losses and reduce any potential bruising. Farmers gently twist each apple once to detach it from the branch, while keeping the stem intact. It is precisely this meticulous attention to even the smallest details that has turned Aomori into Japan's apple empire, contributing around 60% of the nation's total apple production, with more than 450,000 tons harvested each year. But the Japanese always find ways to amaze the world with unusual and highly creative innovations, even in agriculture. Japanese snow apples are one such remarkable product, created through a small, yet incredibly refined technique. Right in Aomori, Japan's apple capital, instead of harvesting apples at the usual time around October to November, some orchards deliberately leave the fruit on the trees until December, when hundreds of hectares of orchards begin to be covered in snow. This method is called yuki ringo. Its principle is quite simple, but extremely effective. As temperatures drop and snow blankets the orchards, the apple's metabolic processes slow down. The water content gradually decreases while the natural sugars become more concentrated. The thick layer of snow acts as a natural insulator, preventing the fruit from completely freezing and instead cold aging it right on the tree. As a result, Yuki Ringo apples develop a richer sweetness, a more pronounced aroma, and a crisp texture that stands out compared to ordinary apples. Meanwhile, in regions with extremely heavy snowfall, such as Niigata, where snow can pile up more than 2 to 3 meters deep during the peak of winter, the Japanese take advantage of nature itself as a massive, completely free cold storage system. After being harvested at the end of autumn, The apples are packed into wooden crates or specialized plastic containers and transported to natural snowfields located near the orchards. There, farmers arrange the crates in clusters either directly on the ground or inside compacted snow pits prepared in advance. On top of the crates, farmers place a thick layer of conifer branches, such as pine or cedar, creating a natural insulating cushion that also allows air to circulate. The entire area is then buried under several meters of snow. In some cases, specialized snow-blowing vehicles add extra layers of snow to reinforce the mound, forming a stable natural cold storage chamber. With temperatures staying close to 0 degrees Celsius and fluctuating very little, the apples can be preserved for months, while maintaining their crisp texture, moisture, and fresh flavor. Long after the main apple season has ended, these snow-aged apples finally reach the market as a premium early spring delicacy, often selling for up to 3 times the price of ordinary Fuji apples. Many people describe Japan as another planet on Earth, a place where seemingly impossible ideas work flawlessly and create enormous value. A striking example is the square watermelon. Forced out of its natural shape to optimize storage and transport, yet sold as a luxury display item for up to $800, dozens of times more expensive than a regular round watermelon. Everything begins with a young melon, no larger than a fist, placed inside a transparent, tempered glass mold secured with sturdy steel latches and bolts. Japanese farmers monitor the fruit's growth pressure every day, adjusting the tightness of the frame to ensure the melon gradually expands and fills the square corners of the mold without cracking. At the same time, each fruit is wrapped in paper to limit direct sunlight, helping the rind maintain an even green color and perfectly straight stripes. After about 45 days, earlier than the usual harvest time for regular watermelons, farmers begin harvesting. Only melons that fit the mold perfectly, with flawless surfaces free of scratches or cracks, are classified as premium grade. In Zentsuji City, Kagawa Prefecture, the number of melons that meet this standard each year is only around 200, all of which receive an exclusive certification label before entering the final stage of luxury packaging. Because they develop in a way that goes against nature, these square watermelons, despite their striking and unusual appearance, offer a flavor that is merely edible. Their true value lies not in sweetness, but in their one-of-a-kind geometric shape. If there is a Japanese delicacy that diners are said to risk their lives to taste, it is pufferfish, a species that contains tetrodotoxin, a poison about 1,000 times more potent than cyanide and with no known antidote. Yet in Shimonoseki, a port city in Yamaguchi Prefecture, around 1,000 tons of pufferfish are traded each year, making it the largest pufferfish distribution hub in the world. Most of the catch is brought to the Heitomari Fugu market, a marketplace believed to be the only one in the world dedicated almost entirely to this dangerous fish. Here, auctions take place in an unusual silence using a unique bidding method known as fukubiki. Instead of announcing prices publicly, traders hide their hands inside a black cloth sleeve and signal bids with their fingers, ensuring that the agreed price between buyer and seller remains completely confidential. Notably, high-quality pufferfish weighing between 1 and 2 kilograms can reach auction prices of up to $100 right on the trading floor. Few people know that to even touch this deadly fish, a chef in Japan must undergo 2 to 3 years of rigorous training. After that, they must pass a strict licensing exam with a very low pass rate to receive an official government permit. In specialized high-end restaurants such as Waras in Tokyo, where even prime ministers are known to dine, the preparation process resembles a precision surgical operation. A master chef can complete the delicate filleting process in about 10 minutes. First, chefs completely isolate the safe white flesh from the parts that contain extremely potent toxins, such as the skin, liver, internal organs, and ovaries. What's important to note is that these parts cannot simply be discarded as ordinary waste. They must be sealed in locked metal containers and disposed of through hazardous waste procedures under the supervision of health authorities, preventing any risk of accidental exposure. Finally, the fish meat is sliced so thin that it becomes nearly translucent, then arranged as sashimi to highlight its distinctive, firm, and springy texture. If 50 years ago, Japan recorded more than 100 deaths each year from pufferfish poisoning, today that number has fallen to around 3 people. And all cases involve individuals attempting to prepare the fish themselves at home. That's why the $200 to $500 you pay for a pufferfish meal is not just for its delicate, refined flavor, but for the absolute safety ensured by the mastery of highly trained chefs. With prices that can reach up to 10 times that of premium Wagyu beef, sea urchin, known as uni, is often described as the pure gold of the ocean, where the soft, creamy lobes hidden inside a spiky shell hold enormous economic value. While many countries harvest sea urchins using industrial fishing fleets and large-scale scuba diving systems, Japan still preserves a tradition that dates back more than 1,000 years. Hand harvesting by the ama, female free divers capable of descending to depths of up to 20 meters without using oxygen tanks. In cold, fast-moving waters such as those around Hokkaido, the ama must immerse themselves in seas only a few degrees above freezing, weaving through underwater rock reefs to collect sea urchins tightly wedged into narrow crevices. On average, during a single diving session, an ama gathers only a few dozen specimens that meet the required standard. A modest yield, but one that reflects an uncompromising commitment to quality. Once brought ashore, the processing of sea urchins becomes a test of almost absolute precision. The spiny shell is carefully opened entirely by hand to extract the 5 golden reproductive lobes inside. Because uni has an extremely delicate structure that can easily melt when exposed to warm air or fresh water, workers must move with great speed while keeping their hands perfectly steady. They then gently rinse the uni with pure seawater to preserve the fine strands of flesh on the surface while maintaining the natural dryness of the meat. In particular, only uni lobes with a bright golden orange color, a smooth, firm surface, and perfect dryness are graded as top quality. At Toyosu Market in Tokyo, premium trays of uni weighing just 250 grams can fetch between $400 and $800. Making sea urchin one of the most valuable seafood products in the world when measured by weight. Leaving the rocky reefs behind, the massive 2-kilometer-long trawl net you see is designed to trap flying fish, a species capable of gliding through the air at speeds of up to 60 kilometers per hour to escape predators. Taking advantage of ocean currents where the schools gather most densely, fishermen deploy the nets deep beneath the sea before quickly closing the circle. Once the net tightens, powerful pulley systems haul tons of fish onto the deck. The moment they reach the boat, the catch is immediately buried in ice at temperatures close to 0 degrees Celsius to lock in freshness, an essential step that preserves the purity of the fish's flesh and prevents decomposition from the instant it leaves the sea. It is from this point that the value of Japanese flying fish rises dramatically through the yakiago process, grilled and dried flying fish. After cleaning, the fish are arranged on racks and slowly grilled for about 3 hours to remove any fishy odor, while concentrating their natural umami flavor. They are then sun-dried and further dehydrated with warm air for several days until the texture becomes firm and almost rock-like. From every 10 kilograms of fresh fish, only about 2 to 3 kilograms remain after grilling and drying. In return, The natural sweetness and umami are intensely concentrated. Just a few pieces of yakiego are enough to create a deeply flavorful dashi broth, the foundation of many premium ramen bowls. Brazil is one of the rare countries where the cattle population outnumbers the human population. More than 200 million head spread across endless grasslands, turning the nation into the world's beef superpower. Brazil does not only raise familiar beef and dairy breeds, the country also possesses astonishing giants. The pure white Nelore dominating the pastures, the heavily muscled Belgian blue weighing over 1,000 kilograms like living blocks of steel, and the Holstein Friesian capable of producing dozens of liters of milk each day. In Brazil, cattle are not raised by traditional instinct but managed like high-performance athletes. Livestock systems operate with precision, featuring automatic massage machines that stimulate circulation, enclosed barns controlling temperature and humidity, and feeding, cleaning, and milking lines running continuously on optimized cycles. Here, livestock farming is no longer just agriculture, but has become a large-scale nutrition production industry, where technology and biology combine to maximize the productivity of each individual animal. Farewell to the cattle ranches. The journey takes us to vast acai forests stretching across the Amazon, where Brazil supplies more than 90% of the world's acai production, creating an industry worth over $3 billion each year. The acai tree is a tall palm that grows widely in the Amazon rainforest, bearing small clusters of fruit hanging in bunches. The fruit looks like blueberries but is deep purple, almost black, with thin flesh and a large seed, so it is usually blended into smoothies or acai bowls rather than eaten fresh like other berries. The acai harvest season begins when Amazon locals tie a pacona strap around their ankles and climb straight up palm trunks over 20 meters high using only their strength. No ladders, no safety ropes. They move like Spider-Men through the deep forest, repeating the motion hundreds of times each day. The purple clusters are cut down and must be processed almost immediately, because within just a few hours they begin to oxidize and lose their natural value. For this reason, grinding and freezing stations are placed right beside the forest, operating continuously to preserve full quality. Remarkably, these tiny acai berries have helped change the fate of the Amazon. If forests were once cleared for cattle ranching, today acai provides a more stable source of income, allowing many forest areas to remain intact instead of disappearing. Few crops are such that the more they are sustainably harvested, the stronger the incentive becomes to protect the entire forest. It would not be an exaggeration to say that if Brazil were to suffer a soybean crop failure, the livestock industries in Asia, Europe, and the United States would face a severe shock, as Brazil currently accounts for more than 1/3 of global soybean trade and acts as a regulating valve for the world's feed supply. Compared with the United States or Argentina, Brazil's soybean sector stands out for its vast contiguous fields cultivated in 2 crops per year, and its fleet of ultra-wide, highly automated combine harvesters operating more like a continuous industrial production line than dispersed mid-sized farms. From January to March, under the late dry season sun in Mato Grosso, combine harvesters roll into the golden sea of soybeans, lowering their headers close to the ground to gather each row with near-perfect precision, while internal systems continuously thresh and screen to ensure export standards. The stems and leaves are shredded and spread back onto the soil to prepare for the next safrinha corn crop. Golden soybeans quickly fill the grain tank. Once it reaches capacity, the unloading auger extends toward a truck driving alongside without interrupting the machine's rhythm. With a field capacity of around 50 tons per hour, each machine is not merely harvesting a crop. It is operating a crucial link in the global food supply chain. As soon as soybeans leave the fields of Mato Grosso, Brazil does not slow down. Safrinha corn is immediately sown, opening a new production cycle on the very land that has just been harvested. When harvest season arrives, the perfectly aligned fields are guided by data and synchronized mechanization. Combine harvesters lower their headers, feeding corn stalks into the threshing unit. Augers and stripping plates separate the kernels from the cob within seconds, while the stalks and leaves are shredded and returned to the field to retain moisture. Sensors monitor losses and moisture levels, and the unloading auger transfers grain to trucks driving alongside without stopping the machine. These high-capacity machines can harvest up to 60 tons of corn per hour under field conditions, helping position Brazil as one of the world's largest corn exporters. In addition, harvesting corn for animal feed also plays a vital role in dairy regions and feedlots. Unlike grain corn harvest, which typically takes place from June to August, when the plant has fully dried and the kernels reach safe storage moisture levels, corn for silage is cut earlier, when the kernels are in the milk dough stage and the whole plant reaches about 30 to 35% dry matter. Immediately, forage harvesters enter the field, cutting and chopping the entire plant into small pieces before blowing it into trailers running alongside for transport to silage bunkers, creating a stable fermented feed supply year-round. Like soybeans, corn is a foundation of the global poultry and pork industries. If Brazil were to suffer a crop failure, meat prices in Asia or Europe could immediately feel the domino effect. For this reason, Brazilian corn is not merely a crop. It is a strategic link in the global feed supply chain, where each season is operated and calculated like a large-scale industrial production system. Brazil is the largest exporter of concentrated orange juice on the planet. At times, the country has accounted for more than 50% of global orange juice trade. That means for every 2 glasses of orange juice exported worldwide, 1 originates from Brazil. Every November, the orange groves in São Paulo enter a race against time. Oranges are harvested only when they reach perfect ripeness, because a delay of just a few days can affect sugar levels and juice quality. On large farms, harvesting machines shake the tree trunks or use soft brushes moving along straight rows, synchronized with conveyor systems that collect the fruit below. A modern system can harvest up to 100 tons per day, turning the process into a high-speed industrial production line. But speed always comes with risk. Excessive shaking can bruise the peel, knock off unripe fruit, and affect the tree's vitality. Therefore, in smaller orchards, workers still use shears to cut each fruit by hand, checking ripeness on the spot to maintain optimal quality. After each harvest, the orchards are pruned to remove old or diseased branches and to create an open canopy that helps the trees recover more quickly. Proper pruning techniques not only stimulate a more uniform flowering cycle, but also optimize yield and juice quality for the following season. In Brazil, sugarcane does not only create sweetness, but also powers an entire energy economy. From straight fields to gas stations, ethanol made from sugarcane fuels millions of engines every day, forming an industry worth more than 60 billion USDs and making Brazil the world leader in biofuels. In the past, harvest season began with fire. Farmers burned the leaves to clear the fields and drive away insects, while also allowing the cane stalks to evaporate slightly, increasing sugar concentration. But long stretches of smoke extending for dozens of kilometers, along with the risk of uncontrolled fires sparked by a single strong wind, forced the sugarcane industry to change. Today, mechanization has replaced the flames. Harvesters cut close to the base with precise blades, and sensors automatically adjust cutting depth to protect the roots, allowing the crop to regenerate for another 3 to 5 consecutive harvests. Leaves are shredded and returned to the soil, while cane stalks move directly onto conveyor belts and into trailers as the machine continues moving, turning the entire field into an outdoor energy factory operating without interruption. Sugarcane harvesters in Brazil are mainly supplied by John Deere and Case IH, designed specifically for vast plantations and diverse terrain conditions. A modern machine can harvest up to 100 tons of cane per hour, operating continuously across multiple shifts each day and delivering raw material directly to the mill in the shortest possible time to optimize sugar content and ethanol production efficiency. A single frosty night in Brazil can burn billions of USD, as the country accounts for nearly 1/3 of global coffee production. If temperatures drop below 0 degrees Celsius, millions of trees can be damaged, supply is shaken, world prices surge, and the entire planet pays for a brief moment of cold. In states such as Minas Gerais and São Paulo, there are coffee plantations spanning thousands of hectares, stretching to the horizon from above like a man-made sea of trees. That immense scale makes manual harvesting nearly impossible, especially when the harvest season lasts only 2 to 3 months. For this reason, Brazil has not only changed the way it harvests, but redesigned the entire production ecosystem. Coffee trees are planted in straight rows with precise spacing so machines can move continuously. During harvest, machines travel along each row with thousands of vibrating rods embracing the trunks and generating controlled oscillations strong enough to shake loose ripe cherries while minimizing impact on young branches. The cherries fall onto soft catching panels on both sides of the machine, then move onto internal conveyor belts. On board, fans and vibrating screens separate leaves, twigs, and debris before the beans are transferred into large storage bins running in parallel behind the machine. After harvesting, all the coffee is transported to processing areas for sorting and drying to reduce moisture to safe storage levels. The most common method is the natural process, in which whole coffee cherries are spread evenly across large concrete patios under the Brazilian sun and turned regularly over many days to ensure uniform drying. When weather conditions are unstable or volumes are too large, farms combine sun drying with mechanical dryers to precisely control moisture, ensuring consistent quality before milling and export. Leaving behind the vast coffee plantations, the journey takes us to Brazil's vineyards, an industry generating more than 2 billion USD each year, where grape cultivation is no longer bound by the world's traditional farming cycles. While most vineyards in the United States or Europe harvest only once a year according to the seasons, in the São Francisco Valley, Brazilian farmers have almost programmed nature itself, allowing vineyards to reach 2 to 3 harvests per year. Premium grape clusters are still cut by hand to avoid damaging the thin skins, while behind them, harvesting machines and specialized vehicles move in parallel along each row. Conveyors integrated into the machines receive the grapes and transfer them directly into containers without touching the ground. Vibration sensors and optical cameras assist with preliminary sorting right in the field, minimizing post-harvest losses. People and technology work continuously under the dry heat of the semi-arid region, turning the fields into a production system operating almost year-round. The result is something that once seemed impossible. Brazil becomes an off-season grape supplier to the world, where Europe's winter begins with harvests taking place in the heart of South America. Most agricultural powerhouses possess at least one of two fundamental advantages: vast land area or a favorable climate. But for the Netherlands, their starting point consisted largely of land lying below sea level. Without expansive alluvial plains like those of France or Germany, most of their territory is made up of polders, artificial lands sustained by dike systems and pumps operating 24/7. Here, agricultural production constantly confronts saltwater intrusion, high humidity, and a lack of natural sunlight. It was precisely these harsh physical constraints that forced the Netherlands to choose a different strategy. Instead of expanding agriculture horizontally, like the United States or Russia, they focused on optimizing value density per unit of land area. At this point, every scarce square meter had to operate at extreme intensity, and even be completely detached from the soil. All of the most remarkable agricultural achievements begin with seeds. And in the Netherlands, more than 200 breeding companies have transformed the country into the world's leading hub of seed technology. Here, seeds are not developed for mass production, but are engineered as a core technical component specifically for smart greenhouses. They possess inherent disease resistance and respond precisely to every milligram of nutrients in a controlled cultivation environment. If the United States has Silicon Valley for software, then the Netherlands has Seed Valley, a hub that brings together more than 40 seed corporations, closely connected with Wageningen University and the government, enabling new plant varieties to move from the laboratory to global production in just a few years. You may be astonished to learn that 1 kilogram of specialized tomato seeds here can cost up to 50,000 USDs, as expensive as pure gold. This extraordinary price reflects billions of dollars invested in genetic research, allowing crops to achieve maximum yields while maintaining strong resilience without the need for chemical plant protection products. With this capability, the Netherlands now controls 25% of the global vegetable export value and 60% of the global seed potato market. From the United States to China, many of the world's leading agricultural systems are directly dependent on plant varieties originating from this low-lying land. Alongside seeds worth billions of dollars, another revolution in cultivation environments was pioneered, standardized, and spread worldwide by the Netherlands: rockwool growing media. At first glance, they appear to be nothing more than soft, lifeless foam blocks. But rockwool is in fact a complete replacement for the role of soil, a survival breakthrough for countries where arable land is always a luxury. The foundation of this technology comes from basalt rock and ores melted at 2,700 degrees Fahrenheit. From this glowing stream of molten material, the lava is spun centrifugally into ultra-fine mineral fibers and compressed into solid blocks. Thanks to its volcanic mineral origin, its superiority lies in its chemical inertness and absolute sterility, creating an almost perfectly clean biological growing medium that completely eliminates pathogens and prevents the nutrient losses commonly seen in traditional soil-based cultivation. Complete separation from soil gives Dutch engineers ultimate control. They precisely program nutrient concentrations and pH levels down to the milligram, delivering them directly to the root system without any interference or loss caused by impurities or unwanted absorption. From there, rockwool's fiber structure creates an ideal paradox for plants. It can retain water many times its own weight while still maintaining ultra-fine air pockets. This ensures roots are constantly supplied with maximum oxygen, completely eliminating the risk of waterlogging and common root diseases. Today, this technology covers more than 80% of greenhouse area in the Netherlands. Each growing block is a critical node in a closed-loop circulation system, directly connected to a central computer. The result is astonishing efficiency, up to 90% water savings and 40% fertilizer savings. And it doesn't stop there. All excess water is collected, sterilized, and reused, turning greenhouses into a sustainable production cycle that achieves the highest yields on the planet. When the Netherlands is mentioned, the whole world immediately thinks of vibrant tulip fields. But on the agricultural map, this is not a center for commercial flower production. It is home to the world's largest tulip bulb production facilities, supplying up to 2.5 billion bulbs globally each year. These bulbs form the foundation of the entire global flower supply chain, especially for massive markets such as the United States. However, to maintain this record-breaking position, Dutch farmers must carry out a decisive process, completely removing the flowers at their peak bloom. A tulip bulb requires 5 to 7 years of care before it is able to bloom. But the moment the petals reach peak color maturity, specialized flower removal machines are deployed immediately to redirect the plant's nutrient flow. Designed with rotating shafts integrated with rubber paddles and cutting blades, the core mechanism of these machines focuses force on the plant's weakest point, just beneath the flower head. As the machine moves forward, the high-speed rotating shaft snaps or cleanly cuts off the flower head without damaging the leaves or stem. Removing the flower head immediately halts seed formation and energy consumption at the top of the plant. This forces all sugars and minerals produced through photosynthesis to be redirected downward, concentrating nourishment into the bulb. By summer, when the leaves have withered, about 2 months after the flowers are removed, the true industrial harvesting process begins. Steel cutting systems lift the entire soil layer at a depth of around 20 centimeters, feeding it onto vibrating conveyor belts that sift and separate the bulbs on site, processing hectares of land each day. The breakthrough lies in crop protection. Despite being industrial machinery, all conveyors are lined with rubber padding and use high-pressure air-blowing systems to protect the thin, sensitive outer skin. This airflow not only removes dirt and fine sand, but also ensures the bulbs are not scratched, crucial for preventing bacterial infiltration during export. As a result, Dutch tulip bulbs grow to 10 to 12 centimeters in size, the gold standard for replanting in the world's most demanding markets. But make no mistake, beyond its empire of bulb production in open fields, the Netherlands still maintains a leading position in professional cut flower production within high-tech greenhouses. After being harvested by automated conveyor systems, millions of flower stems are consolidated and transported to Royal Flora Holland, the largest flower auction in the world. Transportation operates continuously via electric carts moving through an extensive system of sorting warehouses. Each day, this exchange offers up to 20,000 different types of flowers and ornamental plants. For tulips alone, prices fluctuate by the second and by season, but are typically successfully auctioned at an average range of US$0.22 to €0.55 per stem. While other countries require several days for transshipment, the Dutch reverse auction model delivers absolute price transparency and extremely fast capital turnover. Although the Netherlands is not the world's largest consumer market for fresh flowers, it functions as the brain that regulates global supply, allowing tulip shipments leaving the auction floor to land in the United States or Japan within just 24 hours after a deal is closed. With only 1.5 million cows, just 1/6 the scale of California, the Netherlands still amazes the world with record-breaking productivity. More than 9,000 kilograms of milk per cow per year. Each cow is a data node within a farm-wide IoT network. Through smart chips, the system can analyze and predict health risks up to 48 hours before clinical symptoms appear. This level of precision eliminates nearly all random variables, turning farms into an ideally optimized ecosystem. But in the Netherlands, technology doesn't exist only on charts. It takes physical form through tireless field operating machines, Lely robots. In reality, the number of farms in the Netherlands is declining by nearly 3% each year due to environmental pressure and a lack of successors, yet herd sizes continue to grow. Faced with this challenge, an automation revolution became inevitable, and at its center is the Lely Vector robot. Its crane system uses sensors to locate and precisely grasp roughage with a deviation of less than 2%. Immediately afterward, automated pipelines inject exact amounts of concentrated feed, which are mixed by an auger into a uniform blend, ensuring cows absorb nutrients completely and eliminating selective feeding. After mixing, the robot autonomously navigates through the farm to distribute feed. Its smartest feature lies in the ultrasonic sensors. The system measures the height of leftover feed and dispenses more only when necessary, ensuring troughs remain full while maintaining freshness 24/7. Notably, a single system consumes only about 20 kilowatt-hours per day to care for hundreds of cows. This quiet operation, with extremely low energy use, not only replaces human labor, but also creates a perfectly calm environment, key to keeping cows relaxed, maximizing oxytocin release, and sustaining peak milk productivity. To maintain high productivity, every cow needs a continuous energy intake. However, cows tend to use their noses to push feed sideways and out of reach, causing feed to scatter and go to waste. Lely Juno is designed to solve this problem. The robot operates as an automated system that moves along feed alleys 24/7, gathering and pushing feed back toward the fence. Keeping feed constantly within reach not only minimizes waste, but also stimulates cows' natural feeding behavior. Real-world results show that Lely Juno increases dry matter intake by 3%, equivalent to nearly 1 additional kilogram of milk per cow per day, simply by optimizing how feed is delivered. In the past, milking was the most exhausting burden for farmers. They had to wake up at 4 to 5 a.m., manually operating equipment for hundreds of cows on a forced schedule. This process not only drained human energy, but also placed significant stress on the herd. The Lely astronaut robot completely changed the game with a voluntary principle. Cows independently choose to be milked whenever they want, averaging 2.5 to 3 times per day. As soon as a cow enters position, the system scans its smart tag to retrieve health records and dispenses the exact amount of concentrated feed tailored to that individual. Notably, the robot is capable of real-time quality control. Sensors continuously analyze parameters ranging from electrical conductivity and fat content to somatic cell counts. At the slightest sign of mastitis or any indicator falling outside standards, a diversion valve immediately redirects the compromised milk into a separate tank without any human intervention. At the end of the process, the milking cups automatically detach and retract to a standby position, never touching the floor to ensure hygiene. The milk that meets standards then flows directly through a rapid cooling system to below 4 degrees Celsius before entering the main refrigerated storage tank. This entire journey takes place in a closed system, preventing any contact with air or bacteria. Beyond boosting milk yield by an additional 15%, this robot redefines livestock farming as a smart production line where humans manage data while cows are free to live according to their natural biological rhythms. Today, high-tech greenhouses can be found almost everywhere, but the density and scale in the Netherlands remain in a class of their own. Here, more than 9,000 greenhouses with a total area of up to 10,000 hectares are not crude plastic structures like those in Spain, but complexes of tempered glass operated by combined heat and power systems. By using natural gas to generate electricity for LED lighting arrays, then recovering waste heat for heating, these systems maintain a stable growth cycle 24/7, producing light so intense it can be clearly detected by satellites at night. There is an intriguing paradox. While the world struggles with emissions, Dutch farmers actually purchase industrial CO2 as fertilizer. Through a massive national pipeline network, excess CO2 is transported directly from refineries at the port of Rotterdam straight to the roots of plants inside greenhouses. After being injected through ultrafine piping systems, this CO2 allows plants to photosynthesize at extreme levels, accelerating growth cycles and increasing yields by up to 30% without expanding cultivated land. The pinnacle of this optimization is tomatoes, the #1 crop in Dutch greenhouses, with total production nearing 1 million tons per year. Despite the modest land area, export value still reaches $2 billion USD, making the country the world's second largest tomato exporter. Their strength lies in ultra-intensive cultivation. A single tomato plant can be harvested continuously for up to 11 months, thanks to hanging systems over 10 meters high and root systems neatly contained in inert growing media. This creates a stable, year-round production cycle, something that outdoor agricultural systems in Southern Europe or North America simply cannot sustain. Now let's head to California's Central Valley, the heart of America's plum industry, supplying more than 40% of the nation's production and operating one of the most refined, high-efficiency harvest systems in the world. Across meticulously designed orchards, rotary brush harvesters glide down the rows. Soft rotating brushes snap ripe fruit from the stem with precision, then move the plums onto cushioned conveyors to minimize bruising. At peak performance, a single modern machine can bring in up to 3 tons per hour, with losses kept below 3%. But in hilly terrain, wide canopy orchards, or old plum groves, shaking machines take the lead. Their hydraulic resonance clamps grip the trunk and send controlled vibrations through the canopy, shaking fruit into funnel-shaped catch frames or side troughs. Compared to rotary harvesters, shakers demand careful setup, but deliver faster, cleaner results and excel in complex landscapes. Each year, the United States brings in hundreds of thousands of tons of plums, thanks to powerful mechanization, meeting both domestic demand and the needs of global processors. Taro, a starchy, sweet, nutty-flavored root, is widely cultivated across the humid, tropical regions of Asia, the Pacific, and Africa, and its harvesting method is truly distinctive. Unlike many other root crops that can be mechanized, taro remains loyal to the farmer's hands. Buried beneath 30 to 50 centimeters of mud, its roots interlace into dense, firm clusters, gripping the soil so tightly that no ordinary pull can lift it. At that moment, seemingly simple tools, sheath knives, pointed wooden hoes, or curved bamboo hooks, become instruments of precision. Harvesting each clump requires both strength and technique, loosening the mud just right, guiding the blade with accuracy, and pulling the rhizome in one decisive motion. A single misstep can snap the corm or bruise its skin, instantly reducing its value. Although mango is a globally popular fruit and a key export crop for many tropical countries, about 90% of the world's mangoes are still harvested entirely by hand. From March to June, major mango growing regions across Asia and Central South America enter their peak harvest season. For low canopy trees, farmers harvest by hand, judging ripeness through the tautness of the skin and the subtle elasticity of the flesh. A skilled picker can harvest up to 300 fruits per hour, while a less experienced worker may need 2 to 3 times longer for the same amount. When cutting, they always leave a short stem to prevent mango sap, a highly acidic latex, from staining the peel or causing skin burns. To reach fruit in the upper canopy, long-handled cutting poles with built-in catching baskets serve as an essential extension of the arm. On large farms, hydraulic lifting platforms allow workers to reach heights of 5 to 6 meters safely and steadily, boosting productivity by 2 to 3 times, compared with traditional hand harvesting, and contributing to more than 40 million tons of mangoes each year, a figure still rising in response to global demand. Advancing across the navy bean fields is one of the most advanced dry bean harvesters in use today. With a closed-loop cut-thresh separate system operating in a single pass, it cuts harvest time nearly in half and boosts productivity to up to 5 tons per hour, a level manual labor could never achieve. Meanwhile, some farms in North America still rely on swathing and windrowing, cutting plants when pods are about 80% dry, laying them in rows to cure naturally for 1 to 2 days before the combine moves in. This method helps stabilize moisture and reduce losses. The name Navy bean traces back to its role as a staple food on U.S. Navy ships in the early 19th century. Today, although less globally common than mung or black beans, navy beans remain vital in states like North Dakota and Minnesota, producing hundreds of thousands of tons annually. Recognized as a natural superfood and contributing significantly to U.S. agricultural exports.